All right, transistor, like a switch or solenoid, or looking at one as a switch or solenoid. It can be, as it was shown, you can use it for a lot of other things, but just looking at it like this, it's a very easy way to kind of start and look at how to use the transistor work. It makes sense to me. So if we look at it, something like this, you should know what this is by now. If I drew it nice. All right, circuit breaker. Some sort of load. What do I got here? A relay. With a switch. So what happens when I close, point there and a point there, when I close this switch, what happens? Relay comes down and power is going to go through to my load. Well, I can do the same thing over here. Just kind of make it look like this. How about that? So kind of the same thing. So if I close this switch right here, current's going to flow through the coil, cause an electrical current to flow through here, creating a magnet which will be set up as a solenoid to drop that bar down to allow current to go through. Same thing over here. Close this switch, assuming there's a ground. That would then create a current flow through here, which will allow bigger current to flow all the way through the transistor.
Why would you use one over the other? Is one smaller?
Well, yeah, the transistor is, it's like that's just a connection of something here, but I mean, they're tiny. They're little tiny things. I mean, they're very small. You'll see them. They're in your kit right there. Your magneto kit, there's some transistors in there, but they can be very, very, very small. And now, but you have to think of the application. Would I want to use a very, very tiny or even a moderately sized transistor to go to my starter motor on my car, on my airplane? You'd replace it pretty often. I don't think they make them that big. So I'd want a nice big steel bar that comes down, or the master solenoid in my aircraft. I turn it on, you hear a clunk. Okay, that is not a little tiny diode. But at the same time, when I turn my radio on, do I want this solenoid inside of my radio going clunk? No, I want a little transistor in there, something solid state that's not going to wear out and give way. All right, so the confusing part, we're still figuring that out.
So I'm just trying to make sure that's an NPN switch, or not transistor, excuse me, not switch.
It's pointed in,
Yeah.
so. So that becomes, so what type is this one then? PNP. PNP. So what does the base need?
Negative.
And what is it getting?
Negative.
Yeah. Okay, so the confusing part becomes how they are connected and what makes them work. So C for connection. So transistors must be properly connected. So they must be properly connected. Which means you can't just throw it in there and hook a bunch of wires up and expect it to work. Well, come on. Got 3 connections. How hard could it be, right? So let me see. If I did something like this. We'll keep it going this way. Not pointed in. We'll put not pointed in. There we go. Type is that? Okay. And so, let me think. This would be the emitter with the arrow on it. This is the collector, and that's the base down here. Base down here. So, let's see. So, emitter to base junction. I'm going to write this, and then I'm going to come back around. So, emitter, but I'm just going to use letters. See, emitter to base junction. Base junction is forward bias. Forward bias. Which is to say the base is positive and emitter is negative. And then I'll say in PNP, emitter is positive to the base. So I can go on with like this and say, okay, so right here, the PNP, the emitter to, I'll use red, emitter to base junction is forward biased. And then I'm going to go on to say the base to collector. So this is going to be reverse bias, reverse, and the red must be forward. And you're going to kind of go, what? And I'm going to start to lose you here in a second, huh? Okay. So this is where I came up with this idea of, now I'm almost reluctant to keep writing this, but I just will. But don't go away at all. Don't go away mad and don't go away. So base to collector is reverse biased. That is in an NPN, the collector is more positive than the base. Is more positive. Positive than the base. And in a PMP, the collector is negative in respect to the base. But then I kind of had this thing where I thought, oh my God, this is just like so, what the hell are you talking about kind of a thing. And so I came up with this idea, but I have to warn you, this is where I was so proud of myself for this, and then I have an electrical engineer go, that's not right. But, can I move this? Okay. No? Yes? No? You got it? People at home are getting bored with me. Okay. You understand it? All right, so let's take a look at it just a little bit different way. So let me see, I got black here, I got black. Okay, so we'll do this. Draw one here. So if we use the same convention, we're going to say this is the base down here, the base, and then we'll put this out here. We'll call this the collector. I'll keep it with my drawing that I got over here because I like it. Emitter, and this will be a what type? What type I got here? Not pointed in. Okay. And so in this one, not pointed in, just a minute ago I was saying the emitter, let me see, I'll back up. Emitter to base junction is forward biased. So we'll make some notes here. So emitter to base is forward. And then I said that is, and then the base to collector. So the base to collector is reverse. And you try and remember all that. But then I thought, wait a minute, what if we did it like this? You just tell me if this works. We're just going to redraw it. Wait a minute, I have a better idea. Draw this a little bit different. This way. This way, this way. So now we have an NPN, and now we're just going to do it like this. So that's kind of what's going on in there. And we can now take a look at it and dissect it just a little bit different than what we had before. And now we can go back to looking at it like it's just some diode. And so if I want to look at it like it's a diode, and if I want to look at the collector to base junction, all I got to do is just look at this right over here. So I can actually come over here and I can erase this for a minute and I can say, what turns that on? The base has got to be what?
Negative or positive?
Positive. Oops. Positive. And this has to be negative. That wasn't so hard, right? Okay. Let's throw this back in here. That's an N. So the emitter to base, this is the emitter to base. I could have done that one first. Emitter to base, so that to that. This has got to be positive, and the emitter has to be, I should have went that way first. That has to be negative. Okay, so emitter to base to emitter, that's this way through this way, and that has to be positive to negative, and that is considered a forward or reverse bias. Forward. Okay, then I said the base to collector, that's the base to collector, has to be reversed. Well, why is that reversed? Well, let's see if we can kind of dissect this a little bit and make sense of that. So base to collector. So I would want this to be somewhat negative and this one to be blue. Negative, well, I don't want to confuse that. So let's take a look at which way is the current flowing here. So which side is going to be my positive? The current, the collector or the emitter? The collector. So, all right, so we're going to go collector is positive and emitter is negative. Happy with that?
No.
What's that? Let me see here. Okay, so collector, let's do it this way. We do conventional theory, collector, this side, so over here, collector is the output. So this is output. And the emitter is input. Now, why is that input? Why? It's backwards, right? The collector, you're going to collect something. Well, wait a minute. No, collecting is bringing in, right? Okay, remember, this was all thought of back when everything was reversed. The positive current flowed from positive to negative. So if you remember that, it was positive to negative when they thought of this, right? Then that makes sense now. From positive to negative, the collector collects all the electrons in, right? And then it goes into it, and then it emits them out. Well, it doesn't work that way anymore, does it?
No.
Because it's all backwards. So now we got to think about it backwards so we can get on board. So just switch it. So the collector is now the output and the emitter is the input. Backwards names. Right? Well, it's because the convention changed. So, what's that?
They couldn't just leave it?
Well, once they figured it out, then you can't rename everything, right? Okay, so you just got to remember that it's a little bit backwards. And so when we look at that, and I say the emitter to base, it's got to be forward. So what's going to turn it on? The emitter to base. So emitter, that's the input. That's where the electrons are coming in this way, right? So that's going to be my negative side of the battery. It's going to hook up to negative. And so what am I going to put on the base? Well, you know there's a P, so you know it's positive. So if the P down here is positive and this is negative, and you hook the battery up over here where it's negative and the battery over here where it's positive, is that forward or reverse bias? Forward. And is it going to be on or off? On. Okay, that's not hard. Just look at it right there. P, and think of it as a diode. There's just a diode stacked in there, right there. That red line is nothing more than a diode. And you have to remember that the emitter is the what side? The input or output? Input, because it's backwards. The output is called the collector. I wish I could remember I had a little saying, and it really worked out well, but I just can't remember it. I know, or I won't, and it was gone, and I should have wrote it down somewhere. I don't know if I wrote it down. I have all these little odd pages where I've written notes. I'm like, oh, that'd be good to tell them. And it kind of started to make sense when I did this. So, and it seems to work pretty well. Yeah, I just didn't write it down. Whatever how it was one day. Okay, so then in the notes, what I've got, I wrote it down. You know, trying to explain that. What I said is the base to collector is reverse base to collector. I'll use a different color here. Base to collector is reverse bias. Well, what does that mean? Well, that kind of means that, and that's where it gets tricky. This more negative, less negative stuff. So the base to collector is reverse bias, which means that. I don't want to. I think maybe this one is. I think if I just leave it alone, you're going to be better off. So that turns it on. Yeah, let's do that. I think that's what I did. So that turns it on. So the red turns it on. So once it's on, what's going to happen? Current's just going to flow across. So that's kind of how I do it right there. If B to C was forward biased, this would be. Yeah, it doesn't work that way. So there we go. So you just got to remember it that way. Whenever you see something like this, I just draw those in. I look at the base. I look at the emitter, which is the input. Make sure it's forward biased, and that's how it's going to be hooked up. So do it one more time. Just see if we got it. All right. So we've got diode. All right. We got the base. We've got emitter, collector, and there we go. So what do I got? The PNP. Okay. So now I've got to figure out how to hook this up. All right. So I'm just going to come over here. Just draw it out. I've got a PNP. All right. Emitter. Is that input or output? Input. So this is my in, this is my out, this is my base. Okay? The input to base, the emitter to base must be forward or reversed? Forward biased, okay? So that means the base is going to be, and the emitter is going to be positive. Okay. Going to get current flow through here. It's going to be on, and then my current will flow that way. Not hard, is it?
Forward relative to what?
To itself. This is negative, and that's positive. So that's forward bias. It would be reverse bias if I hooked the positive right up here and hooked the negative up here, because another way of looking at this is, let's see. I'll make sure I draw it right now. There. It's a bad drawing, but there's a diode. And so this right here, what do I have to do to turn this one on? Which down here on the base? This got to be negative, and this has to be, that's forward bias. If I hooked it up this way, negative here and positive here, that'd be reverse bias, right? Okay. And then let me think. Could probably add, if I thought about it, probably add another diode in here to make it more sense. But I don't want to screw it up and be all like, what? Let me think. All right, one more. What's that? Yes. Yes. All right, so I made a drawing. Oops. I'll do it this way. Yeah. It's a little backwards battery. I don't know why I did that, but I did it. Okay, so it went this way. That's how it should be. I did this. And I said NPN. Down here. Is it on or off?
Off.
Why?
No power.
No power, okay. Okay, so if we had a 12-volt battery, how many volts do I have right here?
12.
Positive 12. How many do I have here?
12.
But it's the negative side. Okay, so to turn this on, it's got to be forward or reverse bias. Forward or reverse biased. Where's the collector? Where's the emitter?
Collector's on the left side.
Emitter's on the right.
Emitter's on the right. Okay, so collector's here.
Really, it looks like it's gonna be opposite. So that looks like the emitter.
Emitter, collector. Electrons are flowing this way. They go into the emitter. Okay, so emitter, collector. So to turn it on, it has to be forward bias between the
Emitter and base, or the collector.
collector or emitter.
Collector and emitter.
Emitter and collector. So remember, electrons are flowing this way. So they're going to come to this point right here. I want to turn it on. If you can think about that way, think about, well, they're not flowing this way, so this would be nothing here, right? So electrons have flown to this point right here, and so they're going to come down here. So just, this isn't accurate, but if it helps. So they're right here. Now, which way has it got to go to turn this thing on? Towards the collector or towards the base? Okay, it's got to go to the base. So it's got to be forward or reverse bias. Forward. Okay, so it's going to come down here. What do I have down here? Now I've dropped some voltage. This is the positive side of the battery. I've dropped some voltage, but this is still positive in respect to this, is it not? So maybe this is 6 volts, but this is still a positive 6, and this is a negative 6. So hey, that's happy with that. So there it goes. Boom. It's going to come down this way. Just because I've dropped the voltage doesn't mean it's not going to work. So that's going to be on, and then this is going to flow across here, right there, and then let me think. Base to collector, base to collector. Base to collector, is that forward or reverse bias right now? Why is it reverse? That's a hard one. Why is it reverse?
Because it doesn't flow that way.
Well, I mean, what does reverse bias mean?
On one side of the diode, so it pass.
So if I've got a P and an N, and I hook the negative side of the battery up here and the positive side here, is that going to flow? It's called reverse bias. Everybody with me on that? Okay, so I've just made a diode right here. That's all that is in blue. It's just a regular old diode. It's got the P on the one side, the N on the other. That is a diode, right? And I've hooked it up in reverse or forward bias. I don't hear a lot of people. Did I lose you?
A little bit. Not really.
I can back up a little bit. I'm okay.
This drawing is helping now.
Okay.
No, this makes me worse.
Is it? Don't look then. There's a diode.
Yes.
If I put the positive here and the negative there, is it on or off?
On.
Okay. Here's a diode. It's the same thing.
Yep.
Okay. Is it on or off? Is that forward bias or reverse bias? Forward. Okay. Here's another diode. It's the same thing. I'm just not drawing a triangle. And I'll make this one the P and that's the N. And I put the negative here and the positive there. Is it forward or reverse bias?
Reverse.
Is it on or off? Yeah, it's so easy, isn't it? This would be a 1, that'd be a 0. On, off. All right, follow me so far?
Yeah.
Okay, now just take these little squares that I drew and kind of look at it diagonal a little bit. So we just backed up a little bit here, and I said, okay, we have an N and a P. That's just a diode, right? And to turn it on, I've got to have what on this top side? And then down here, I got to have a positive, and I did that. I got negative 12 here, and I got positive there. Is that forward bias or reverse bias? Forward. So it sure is. Okay, now let's look at this going this way. So I've got a positive 6 here and a positive 12 there. So this is the negative, so is that forward or reverse bias? It's reverse because this is a positive 6. That's like getting negative. And then I have a positive 12, that's more positive. And plus 6 is less positive, so that makes it the negative side. And so is this forward or reverse bias?
Not be reversed.
It'd be reverse bias. All right, so now we kind of explain that, but to me that just complicates things. If you could just look at the emitter to base and go, okay, that's got to be forward to turn it on, you're pretty much 90% of the way there. And then, of course, it's just an NPN. You add the N, and you hook up the negative to this side. You got, obviously, the positive's got to go on the other side, or it doesn't work. And so there you go. So that's why I say that the emitter to base, the base has to be forward bias, and then the collector to base, the other side, is got to be reverse. And that's how it happens like that, and that's the way it goes. So, okay. Let me see. Hopefully that makes some sense.
So we expand on it later?
What?
Will we expand on that later?
We don't really need to by much. We can just play with it just a little bit. So what do I got here?
Not expand on it, talk about it more?
Yeah.
Yes, talk about it more.
All right, I like
Can you
that.
put a love
Okay.
story behind it?
They don't like each other. No. Let's see, slideshow from current slide. Okay, so we talked about that. We figured out the pointy side, the not so pointy side. Maybe I could have showed you this a little bit ago. Voltage measurement. The point, but I'm really trying to be very careful. I don't want to hurt anybody. So you should have seen something like this at some point in your career here. I know it's like, what? A battery and 2 resistors? I've never seen such a crazy thing.
Who is Ohm?
And when you are, so there's this thing called ohm, right? So when you look at something like this and I say, well, what's the voltage drop across this resistor? And you tell me some craziness about, oh, that's a variable resistor and it's going to be dependent upon the current flow. And I'm like, what? All right, but back to this. So we just have a simple circuit, a battery with 2 resistors, right? You guys have all been there.
Yes.
And I always say, what is the voltage drop across R1? And you are going to put the red lead right here because it matches up to this side, and you are going to put the black lead over here because it matches the negative side over here. That's what you would do, right? I would hope. And you would give me some voltage reading. And I would say, wow, do it again on voltage 2. What's the voltage drop across voltage 2? And you would pretty much do the same thing. You'd say, oh, well, the black side goes over here, and the red side is going to go over here because that's going to be dark red, but it matches up, right? And so, and you're going to be happy, and you're going to move on, and there'll be no problems. But you have to stop and think about, well, wait a minute. You had the red lead and the black lead both at B. Well, how can that possibly be? Is it positive or is it negative?
Both. Depends on what you're measuring.
It's kind of both, isn't it? So point B is negative in oops. It is the, how are you going to get anything done? I keep screwing with this. It is negative in respect to A, but is positive with respect to C, which is to say that there isn't an absolute, like this is the negative side, that is the positive side. And so that's where we get into this more negative, more positive, less positive kind of a thing. So you kind of have to think about it in absolute. So B is, of course, more positive in respect to C, but B is more negative in respect to A. Okay. I think I drew this. Yeah, we drew this a little bit ago. So, yeah.
Can you think of the base, like the wire coming off the base as a signal wire, and so will it have
A signal wire?
2?
I can't think of it that way, no. But you can. It'd be okay. Yeah. If we were getting into
Will one be negative, one be positive?
the base wire,
The base wire?
if it's a PNP or NPN,
Yeah,
yes.
Yeah, okay. That's where my mind was. Then you started going off into the other drawings, and I just confused the heck out of me for some reason.
Keep thinking of it as a signal wire.
So if we were getting into amplifiers, then yeah, it's the signal wire. So a little bit of positive here makes a whole bunch of positive going that way. So then it becomes the amplifier. But we can also look at this and say, without even looking at this arrow, just forget about the arrow and look at it. Okay, so the base is coming down here. It's got a negative right there that I've got right here. That's my circuit breaker. So that's got to be a positive. So that's a positive. And this is looking for a ground. So that's negative. So that'd be a P. This is an N. So that makes that a P and P. Is it pointed in? Yeah, it is pointed in. So there we go. It's a PNP. So not hard, right? And so the P to N junction, the emitter to base junction, emitter to base, that's got to be forward or reverse bias.
Forward.
There we go. It's going to turn it on. What if it's reverse bias? Well, then it's off. Right? So it doesn't really get harder than this. Okay, I guess it does a little bit. Let me think. Which one is this? 663. Okay. Typical light control circuit with a dimmer. All right, light control circuit with a dimmer. So I don't know, here's a little light bulb right here, and this is the dimmer circuit right over here. So there'd be a little control that would move this up and down. So this moves up and down. So it could go, let's see, more positive or more towards the negative. And so what kind of diode do we have right here? Okay, NPN, it's not pointed in for starters. And we've got the emitter over here, the emitter, which is actually where everything comes into, connected to the negative side. Is that good or bad?
Good.
Okay, because this should be an N, this should be a P, this should be an N so far, right? Okay, does that look like it? Maybe if I didn't draw quite so sloppy, it'd be helpful. Let me see. All right. So N, this would be a P, this would be an N, correct? Okay, so I've got a negative over here. That looks good. What is this? P over here is on the positive side. That looks pretty good. Okay, so NPN, so is it reverse or forward bias? Forward bias. So this is going to be going that way. Forward bias. This is negative. That's positive. Forward bias. Is it on or off? So it's on. It's currently the ON position. Let's see. So P1. What is P1? What is this thing here? Give you a hint. Starts with a P. A potentiometer. A variable resistor. Okay, that's pilot controlled right there. So that's what the pilot's going to do. It's going to control it back and forth, back and forth. So moving the baseline towards 3, so moving this down, moving that down, makes the baseline more negative, right? So more negative. And if I move it up, it's more positive. There we go. And so what happens if I go more positive? Let's think about that. And this probably isn't a very proper term, but if I go up and I make it more positive, is it more forward bias or less forward bias? I've never heard that term before. You heard it here first, folks. More forward bias. So would it be more on or more off? More on. So more positive. More on. I'm not allowed to say that. More on. So the light is going to get bright.
Say otter.
Bright. All right. So if I go down, it's going to become more negative, which makes it more or less forward bias. Less forward bias, again, I don't think that's the proper way to say it, but so less.
Sound like there's dim switches in our house?
I don't know if that's what they have in them necessarily, if they're adding resistance or what they're doing per se. So less, so it's less on, so it is dim. So this becomes the more on because it's dim. No, I should do it. So, okay. So see, that's not so difficult, is it? Okay.
If I hit a pothole on the way home, it's all gonna fall out of my head, I'm afraid.
Not that this matters. R1 and R2 are called biasing resistors. These are biasing resistors. And let me see. R1 and R2 are called biasing resistors. R1 is used to create a voltage drop of the battery positive voltage before it reaches a potentiometer. And R2 is lower battery voltage before it reaches the potentiometer that way. So it just drops the voltage. So you don't have a lot of voltage right there. Let's see. I don't think we have to do transistor operation at all. I think I kind of dropped that one out. Because, yeah, that kind of, I think that started to confuse people. Okay, but I think this is a Q&A question. Yeah. Now, when it comes to Q&A questions, yes, you do have the option of simply memorizing something. but there are, I don't know, 1,000 some possibilities. And see, I've seen a progression. Now, back when I took the test, to be honest with you, we graduated on a Friday, and it was, we'll see you here Monday for your tests. The whole class showed up. It wasn't even an option, really. Everybody showed up. You sat in your desk. They handed out a piece of paper and a thing, and the FA test, and the FA proctor had to be here. And you took your writtens and you mailed them off. And you waited by your mailbox 6 to 8 weeks to get your result. There was A, B, C, and D. Then they realized, well, that wasn't very fair, so they dropped the D, and now you only have A, B, and C, and of course you can take it, you take it on a computer, and you get your results the minute you hit the button. Instant gratification. But the one thing that was consistent was that you could read the Q&As, see a question, memorize it to the point where you could just go, I don't know, but it's D. It's just going to be. Or for you guys, C. It just is. Why is it C? I don't know. That is a question that I have given up on. I will never understand that. I just know that it's C, right? And you could do okay. Well, when I took my IA, now the first time I took it, I don't know if I told you guys, but I took my pilot's certificate and my IA almost in the same month. But it was like the day that I hit the 3-year mark of an A&P, man, I was there at the FSDO turning in my paperwork. Now, back in that day, the way you would get your IA was you'd make an appointment with the Flight Standards District Office, the FSDO, and they would say, well, come on down. So you'd show up at the FSDO, and that was kind of a funny story because you had to prove that you owned the library to do the job, because back then it was subscription. You didn't have the internet. So it was all on microfilm. So they said, make sure you got an appointment set, Kevin, for Tuesday. Come on down and make sure you bring your subscription so we know that you got it, because that was part of the regs. And I said, do I have to bring the reader too? I mean, you've been to my shop. You've seen that we have it. And the reader, I'll bring the library if you want. No, you got to bring the reader too. Now, if microfiche readers are about that big, and if they had a print capability, they weighed about 100 and some pounds. So now you got to bring that too. And so I had to, in my car, I had the big microfiche reader and stacks of microfilm, and it took me 3 trips, and they laughed the whole time I was unloading the car. And I brought it in. Where do you want me to set it up? Oh, just over there in the corner on the floor is fine. We just wanted to see you bring it in. So you go upstairs, and they would give you, there was a multiple choice. It was something like 10 questions, but it was the most insane 10 questions you ever had in your life. Then the inspector would just come up with whatever they wanted. And they would come up with stuff like, well, you have a helicopter that has 4,000 hours on the rotors, but it's only got 2,000 on the mast, but it's got, 6,000 on the airframe. And it's all helicopter questions because they're the worst it could possibly be. And, anyway, it goes on and on and on. And they just screw with you for about 4 or 5 hours until they're satisfied that you can do it. And then they say, oh, congratulations, you passed. So I had my IA for some time, and then I just wasn't using it, and I had to go to recurrent training. I thought, I'm not going to use it anymore, so I didn't renew it. And the nice thing about an IA, you don't really have to surrender it. If you miss one of the renewal dates, boom, it's gone. So gone, and then years go by, and I'm like, yeah, I think I want it again. Well, now to get your IA, it's simple. You bring your paperwork to the FSDO, they stamp it, then you go to a test center, and you just take a written test. Nobody gets to mess with you. So I had pretty much, just like before, I had more or less done the Q&As enough, because there's Q&As for IA too, to the point where I had mostly could have memorized them. And so I sat down to take my test, and there was not one question that was the same. Not one. And now, mind you, I have a subscription service to ATP, which is up to the second. It's up to the minute. It's not like I bought books and they might have gone out of date. That's the subscription service I use to give you guys and make the test for you guys. And so I was using that. And so it was up to the minute, up to date questions and answers. No chance I had something that was too old. Not one question was the same. Now I could recognize it as being very, very similar because the drawings don't change. They'll still use the same drawings. But the point I'm making is I've heard that they've done that now with all the A&P tests. More and more students are coming back going, I didn't recognize any of those questions, maybe a couple of them. And so I'm telling you that to say when you're doing your Q&As, you have to look at it and say, the answer is B. It's B because of this. I can explain it to anybody in this class, and you've got to be able to do that. And you know why it's B. If you just look at it and go, it's B, I'll pass the test, you won't. Not anymore. They're making it so that you can't. You have to have that knowledge base. So just wanted to warn you about that. I did pass the test first time. It was very difficult. This is the most difficult test I've ever taken, that second IA test. It was insanely stupid.
Is that 99.9% of people pass going down? Now that there's...
No, our school's still doing 100%. We're still holding it. We haven't seen it go down because we're teaching you the material, not the test. Big difference. So that's why I bring this up. So this is a Q&A right here, and you could look at it and go, nope, I'm just going to pass on that one. Well, you can only pass on so many. So I think the question is, if R2 sticks in the up position, the light will do what? And if an open occurs, I think there might be two Q&As. And if an open, you guys did the Q&As, does that look familiar? Okay, I think one of them is R2 sticks in the up position, the light will what? And if an open occurs at R1, the light will what? Okay, so let's see if we can figure that out. You guys help me, right? If R2, what is this thing right here? This whole R2? Potentiometer. So this moves up and down. If it sticks in the up position, what happens? Oops, I didn't want that. Let's see if we can just kind of figure this out a little bit. Hey, I don't know the answer off the top of my head. I'm just looking at it like for the first time in 2 years right here. First of all, what kind of transistor we got there? PNP? Everybody agree? Well, first of all, it's not pointed in. Okay, so we got the emitter. Emitter is on the which side? It's on the negative side. Let's see if we did this. We got the positive here. Positive, the collector is on the positive, collector on the positive. That makes sense in old-timey, right? Emitter right here is the negative side. That makes sense. Okay? And so, yeah, power would actually come up through here, through the light, back and around this way. So, there we go. So the base is looking for negative. So we have not pointed in. So this is going to be an N type. This is an N type, and this is a P type, right? So it wants a positive down here. Yeah? Okay, and we want it to be forward biased, which means this has to be positive and the emitter has to be negative. So I've got that going. So that looks like that's going to be on. So check one. It is on. It's an NPN. We've got all that done. Okay, so if this slides up, it's going to be more or less negative or positive. More or less positive. Okay. More positive. And down will be more negative. You can say it either which way. Okay, so up, is that more on or more off? Okay, so that'd be more to the forward bias, more on. So that would be bright. Okay, so down will be dim. Dim some. Okay, and if R2 sticks in the up position, the light will? Sounds like it's going to go bright. If an open occurs at R1, the light will open occurs. So this right here is open. So we just kind of, nothing there. So what's going to happen now? Okay, so how is that going to affect it? Well, I'm kind of thinking about right here. If we had a voltmeter right here, a voltmeter here, and this was still here and we had a voltmeter, right? And so this is in series with that, so we could say, oh, maybe we'd have a 6-volt drop here and a 6-volt drop there. But if we get rid of this one, and it's open, what's it going to do? That's a tough one. Oh, what? I don't have the frickin' answer here? Must have wrote it somewhere. That one's a tricky one. I just know for a fact that that one is a very tricky one. And I don't want to give you the wrong answer. Oh. Who's got it out? Yes, it's still going to work. Still going to work. It's going to still be forward bias. I want to say it's stuck on bright. Yeah. Yep, still positive. Oh, come on. How did I not finish that one? Okay. I got it here. Yeah. Sticks up, be on full bright. And I don't think, let me see. Seriously, don't want to tell you the wrong thing. Nobody's got their Q&As?
Cannot be affected, cannot be turned on.
Cannot be turned off.
Yeah, I would say it only.
How come it can't be turned off?
There's no off button.
Well, why was it able to be turned off before?
Because you could put it to the ground and negative side, which.
And this is what I'm talking about. This is the important thing to kind of understand. And it's okay if you look at something and go, I don't know, but then we read the description and go, oh. So the answer is here, the light cannot be turned off. Well, so that means that in this particular position, it can be turned off. Well, how can I turn it off? All the way down. So it's all the way down. So I just don't have enough P coming up in here to actually turn it on, so to speak. So that implies that I can drop the voltage down so low here that it doesn't actually work. Well, if I get rid of R1, I have an opened, and this is just full on positive. I don't really have much of a voltage dropped coming down. So that would look to me like it just is a 12 volts coming through here, and 12 volts. Because the variable resistor has 3 points, 1, 2, 3. So if I don't have the 3 points, then I don't have a voltage drop across R2. If I don't have a voltage drop across R2, it is simply 12 volts. And I can go up and down all day long, and what's my voltage going to be at R2?
12 volts.
Well, yeah, I kind of did say that, right? But you guys got the idea that there will be no voltage drop at R2, so the base is going to get 12 volts. Going to be 12 volts if it's up, 12 volts if it's down. So I move it up, is it more or less positive? It's just positive. Move it down, it's still just positive. It's no more or less, it's just 12 volts. So if you lose this ground, this R1 right here, then it's going to be 12 volts at the base at all times. Follow that?
Yes.
Okay, yeah.
Basically, if there's an open there in R1, then that potentiometer really isn't a potentiometer anymore. It just becomes basically like a pathway just for it to run.
Just a wire.
Yeah.
So if you got just a wire going there, it's like drawing it. Let's see. This kind of comes over here like that. And we just get rid of everything else.
How do I understand AC better than DC? This makes no sense.
The A is before the D.
So, yeah. So if an if an open occurs at R1, the light will not turn off.
That's number 14.
If R2 sticks in the up position, the light will bright. Be bright. Okay. Be on full bright. Yep, that's what I got for you.
So for the, I don't understand how it's, because with the emitter it should be receiving 12 volts, right?
It's the negative side.
Oh wait,
Because it's on the ground.
Remember,
I always thought the emitter was where the battery, like the power source was.
Nope.
Oh, it's back. Oh, the battery's backwards. Got it. Okay.
Well, the positive's up
Yeah,
here.
the positives there. Yeah.
Negative's down there.
And that's on the ground side.
Got it.
By the way, that's how you use straw battery. That's 2, 4, 6, 8, 10. That's 12 volt battery. That's what you have to do for 12 volts. So my electricity teacher was mean. He'd make you do 24 volt batteries. So you'd have a stack going all the way down the piece of paper. So, all right, was that it for that one? Oh, good. I'm glad I was just going to get ready to draw this for you. So this is another one of your Q&As. Which illustration is correct concerning bias application and current? Positive charge flow. Well, that's just a nasty thing to say. So what do we got? So this is looking at right there, not pointed in, PNP. Okay, so that's how I'm going to do that. And then I'm going to say, let's see here. Okay, the base it's hard for you to see base, positive, negative, negative. Okay, so the base here is positive. Is that good or bad? So far I like that. Base here is Negative. Does that match? Nope. Okay. Base here is negative. Okay. Not so good. That's good. So negative, negative. So we know we've got to have emitter to base must be forward bias. So they're saying current flow is going positive charge. I guess that's from positive to negative. So collector in going. That looks good so far. What's the difference between these two? NPN, PNP. Collector, collector, current flow, base, base. It's P, positive. Ooh, what do we got here?
Base.
We got an emitter as a negative, and we got a negative base.
That's not gonna flow. That doesn't work.
That doesn't sound very good, does it?
No.
So we got to have a forward bias on there, which means that this has got to be negative and that has to be positive in order for it to work, or this has to be positive and that has to be negative, and it's got to go that way. So, I don't know, one's looking pretty good. All right, one looks good to me. Say, that's pretty easy to figure out, isn't it? All right, well, hopefully that helped.